Okay, so we completed till the concept of what happens with conservative forces and what happens with non-conservative forces. If I have conservative force, then what will happen is the work due to those kind of forces along any of these paths, if I calculate it, it will be always same. Are you able to get me or not? Yeah, constant, and that can means it is always going to be same also. Hmm. So it becomes independent of path and it only depends upon initial and final point. Okay. So this is, let's suppose this is initial and this is final. So it only depends upon what initial and final point. Are you able to get me? Yeah. So one more thing is there, and for non-conservative force, our terminology is the path is in means basically the work done in different paths will be totally different. Are you able to get me or not? So that can be true also, isn't it? Now, now let us talk about one more case, and that is the talk of spring force and the talk of spring force and frictional force. Okay, are you able to get me or not? Now let us see these things. Let us see these two topics which are most once again most important. Now let us first consider. Let us talk about one case that if I'm talking about spring force. Okay, first I'm talking about spring force. Now if I look into spring force, the force equation is given as F is equal to minus of kx, isn't it? Yeah. So basically, this force is a path dependent force. Basically, the force is path dependent, isn't it? Now, if I just see into the spring force configuration, like let's suppose if I have a if I take a block of mass m, and then with this block of mass m, I attach a spring, and then I apply external force, and then I try to pull it, it gets displaced by some distance. Okay, and then the force in the opposite direction is given as minus of kx. This was our talk of spring force, isn't it? Now, look over there. What we can see is, try to see when I am just displacing this particle, what is happening with this particle? First, if this surface is frictionless, which kind of surface is this? So, if it is frictionless, what will happen with the spring? Spring will automatically go to the extreme point and then it will once again return to the mean point. Yeah, and then once again it will go to the another extreme and it will always oscillate between this extreme and mean point or not. Basically what do you see over here is that one nature you see that if the particle starts from initial point, if the particle starts from which point, it returns to this initial point as it is or not. Basically, if in simple sense I want to talk that whenever I displace the particle, whenever I displace this block from the mean point to extreme point, then what we see is that particle, although after going at extreme point, it is oscillating through this mean point, means it is always returning to the mean point. Are you able to get me or not? So the can we say that the net displacement along whole of this path is basically zero? Yes. Net displacement is how much? Zero. And whichever the energy it was carrying initially, it is having the same energy after returning back or not. So energy, can we say that energy remains conserved over here? But how does the energy will remain conserved if the net work done along the path is zero? Net work done along the path is how much? Zero. So what do we observe that when the net work done along any path is zero, basically it is called as conservative force or not? Because why it will happen is that when I talk about a closed loop, this kind of loop, closed loop, like if this is point A and this is point B, and I take the particle from point A through this path, and then I bring the particle to this initial point through this path, and if the force which is acting over here is conservative, force कैसा है, that means work done along this first path and work done along this second path is always same. Work done along first will be equal to work done along second, isn't it? But since during this closed loop the net displacement is becoming how much? Zero. So basically the net work done will be equal to how much? Net work done will become how much? Zero. Means the what is happening, does the force, as we know that for any kind of conservative path the force is independent of what? Path. Yes, if for any kind of conservative force, for any kind of conservative force the work done is independent of path. Are you able to get me or not? It only depends upon what? Initial point and final point. Now if I am starting from initial point and once again I return back to the same initial point, what will happen? The net work done will be in a closed loop will be equal to how much? Zero. But that happens for which case? If the force is conservative. The force is what? But if I have the same closed loop, but if I have which kind of force? Non-conservative force. If force is non-conservative, and we know that for non-conservative force, work done is not path independent. Yeah. So that means that the work done from initial in this path, in first path, and the second path will be totally different or not? And if they are different again, and we know that if they are different, and since the work done is dependent upon path for non-conservative force, it will not depend upon initial and final point. So work done in the closed loop for which kind of forces? Non-conservative forces will never be zero, will never be equal to how much? Zero. Are you able to get me or not? So the third important property you got, that if I have a conservative force, the net work done in a closed loop is how much? Zero. While for non-conservative force, the net work done in the closed loop is never ever zero. Are you able to get me or not? Yes. Now let us talk about this in the spring case. Spring is doing same thing. What is happening when I'm doing this particular initial energy, means I'm going from initial point to final point, then once again returning back to initial point, energy remains conserved. And that means that the whole work done along this whole path is equal to how much? Zero. Are you able to get me or not? So I repeat it once again. What is happening, that as I know, if I go from initial point and return same at the initial point, that means my energy is conserved. And how it that happens, how that happens basically is if my work done along the path is how much? Zero. Are you able to get me or not? Basically, so that means what? That the spring force is which kind of force? Which kind of force? Conservative, isn't it? Now, if I talk about frictional force, which force? Now, frictional force is also path dependent or not? For different path, I'll have a different frictional force or not? So, frictional force is also path dependent. But if I have any kind of friction and if I take the body from A to B, if I take the body from A to B through two different paths, although it is a closed loop, but the work done along first path will be totally different from work done along the second path due to the presence of friction or not. So that means what? If I say the frictional force, which is although path dependent, the work done in the closed loop is never ever zero for it. And that's why we tell the frictional force to be which kind of force? Non-conservative force. So look over here. Spring is also conservative. Spring is also path dependent. Frictional force is also path dependent. But one of that brings conservation, another one brings what? Non-conservation. Are you able to get? And this brings one more analogy. Look over there, that if I go from initial point to the final point and if the force is conservative, I can return back with the same condition at the initial point or not. And that's why the conservative forces are also termed as reversible in nature. क्या बोलते हैं conservative forces का? Basically conservative forces are reversible in nature. Is that clear or not? And as you know, look over there, when I am going through frictional path, I can't return same. Initial condition is totally different. So that is why non-conservative forces are called as non-reversible. Yeah, irreversible in nature. Are you able to get me or not? So this was all about conservative forces and non-conservative forces. So we will conclude that if I have conservative force and if I have non-conservative force, then there are how many properties? Total 5 properties, isn't it? Basically, for conservative force, first point is work done constant. Second point, independent of path, isn't it? Second point depends upon only initial and final point. Are you able to get me? Third point, if it is constant, independent of path, depends upon initial and final point. Work done by any kind of conservative force in closed loop is basically equal to how much? Zero. Is basically equal to how much? Zero. Are you able to get me or not? Is this clear? Next point. Fourth important point, that work done by conservative forces are reversible in nature. Is this clear or not? Similar, the non-conservative force has the opposite of this. Work done is never constant. This implies dependent upon. Second point, does not depend upon initial and final point. Means for different path, different frictional force will be there. Work done by non-conservative is never zero in closed loop. Fourth point, irreversible in nature. Is this clear or not? मेरी बात समझ में आई या नहीं आई? So these are the basic properties of which kind of forces? Conservative forces and non-conservative forces. Are you able to get me or not? Now look over here. When I talk about this, then we get the distinctions of many conservative and non-conservative forces. So basically, the conservative forces are of 5 types. How many types? The first one is tension. Second one is normal. Third one is gravitational force. Fourth one is electrostatic force. Which force? And fifth one is spring force. Are you able to get me or not? So these are my 5 basic which kind of forces? conservative forces. Are you able to get me or not? Now, the next ones are non-conservative forces. Which kind of forces? Yeah, basically the first example of that comes into the mind as frictional. Second one is also called something by called as viscous force. Viscous force. Third one is also called as something called as drag force. So these are basically the example of which kind of forces? Non-conservative forces. What? We'll talk about that in a greater sense regarding that. We'll come on that. Is that clear or not? Now, as I have the talk of basically conservative force, so let us give the formula of conservative force, isn't it? We'll see that. So let us take an example. Go it or not? ठीक है तो एग्जांपल लें है ना अच्छा अब मानते हैं सुनो जरा लेट अस कंसीडर दैट आई हैव वन बिल्डिंग okay I have this building over here and a particular person is dropping a ball from the top of this building. Means at some height h from the building. Right or not? Consider this height as h1 and consider this height as from the ground as how much? h2. There are two observers. Observer 1 sitting on the ground. Okay, consider it observer 2. And then there is observer 1 looking from the top of the building. Are you able to get me or not? Is that clear? Now, this body has mass how much? M. Mass is how much? M. And if I look into the mass, basically, if I see the consideration of weight of the body, so the weight is going to act downwards, which we are going to call it as mg, isn't it? Now, think of one case. Think of this. Think of. Let us consider that this as your reference point means we will decide our reference point according to the situation. Now, the first case, let us talk about the potential energy of the block with respect to observer on ground. Is that clear or not? So now let us talk of one situation. Now, when the ball will come to this surface, means the ball falls, starts to fall. Right or not? So the ball has came over here. Ball has went over here. It is to the top, just nearer to the roof. Just nearer to the roof of the building. Right or not? Now, if I look over this length is how much? H2 minus H1, isn't it? Now, ध्यान से देखो जरा अगर हम ध्यान से देखें तो अगर मैं ग्राउंड के हिसाब से अगर मैं इसकी पोटेंशियल एनर्जी निकालूं क्या निकालूं तो मान लो अगर इसकी इनिशियल पोटेंशियल एनर्जी को निकाला क्या चीज को निकाला so basically if I talk about initial potential energy this is my initial point and is this is my final point so basically the initial potential energy will be equal to how much mass m basically potential energy का formula क्या होता है mgh this is my potential energy formula or not so basically the initial potential energy will be equal to how much m into g into uh, height with respect to h2 now I'm doing with respect to ground so initial potential energy becomes how much mg into h2 are you able to get me yeah basically with respect to ground the body was at height h2 or not ground yes I'm taking with respect to observer on the ground so what is my initial potential energy mg into h2 What is my final potential energy? Think once again. With respect to ground, I am calculating. Then what is my final potential energy? Where my block is finally. The body is present over here at this height finally or not from the ground. Basically, that height is how much? H2 minus H1. So this is how much? Mg H2 minus. Are you able to get me or not? Yes. Now you know that work done is equal to what? Force into displacement. What is my force? Mg, isn't it? What is my force acting on the block? Mg, and along this direction only, if the body starts from here and comes over here, the net displacement is this height only or not? So how much is that? H1. Now look over here. If I write work done according to that relation as potential energy final minus potential energy initial, then what I get? That is mg into h2 minus h1 minus mgh2. But what is that? Minus of mg into height, how much? H1. Are you able to get me or not? Yeah. So now I'm getting minus. If I use potential energy formula, what I'm getting as minus. But if I use force into displacement, what I'm getting? Plus. So we can basically, if I see the magnitude of it, the magnitude wise, this work done is same or not? Yes. Now, if I look over here, what we observe that yes, sir, you can conclude one conclusion that this means that work done by such of these forces are nothing but minus of potential energy final minus potential energy initial. Basically, can I write like this way or not? And this is the formula of work done for which kind of forces? Now, why conservative forces? Now look over there, look over there. This mg is which kind of force? In nature, the mg is a conservative force. Which kind of force? Mg means gravitational force. And right now we prescribed that the any kind of gravitational force is which kind of force? Conservative in nature. So for any kind of conservative force, what we found, we know that work done is equal to force into displacement, and I'm getting the same thing when I do the subtraction of P final minus P initial. Are you able to get me or not? But that is in negative in nature. So basically, this was the conclusion that when we found the work done, when we calculate the work done with respect to which kind of forces? Conservative forces. So that does not depend upon kinetic energy of the system. क्या इसके ऊपर depend नहीं करते हैं? I'll tell you later. So that means the work done by conservative forces is what? Just right now learn it. It is nothing but potential energy final minus potential energy how much? Initial. Is that clear or not? Now, the point is why it does not depend upon kinetic energy. That's a very good question. Now, you think of initial and final case. Right now, only we described that for any kind of conservative force, the work is only dependent upon the consideration of which point, initial and final point. But when I consider kinetic energy is given as half mv square, isn't it? Now, this velocity is always dependent upon path of the body or not. So that is why the work done by conservative force is never related with kinetic energy. Are you able to get me? Understood? Is this clear or not? Now, this same calculation we are going to do. 1 minute. This same calculation, let me test it. This whole calculation, we took two observers or not? So let us do this calculation once again based upon which observer? This first observer. Which observer? Yeah. So with respect to first observer, the displacement of the particle is just h1 height or not? So work done with respect to observer 1. Basically that is what? Just force into displacement mg into once again how much height? h1. And if I use the term of potential energy, if I want to calculate within potential energy, and as I know that work done by one also it will be just change in potential energy, negative of change in potential energy, because the once again mg is which kind of force? Conservative force. तो ध्यान से देखा जाए तो that is work done by one again is 1 p final minus p initial. Now when the observer is over here, the body actually see that line. This is my observer and the body comes over here. Are you able to get me or not? And I'm measuring from this line. So height is 0 or not? So P final becomes how much? 0. Are you able to get me? Minus of 0 minus initial potential energy was at height h1. So mg into h1. So which comes as mg into h1 or not? Once again. Minus minus it will become plus or not? So basically what we got that once again the work done by 1 in this frame is also same. Are you able to get me? So, what is the conclusion? That day, when we talked about the work done, we saw that when we change the frame of references, we have different work done or not. Now here, when I consider for the conservative force, the work done has become independent of observer. Are you able to get me or not? ध्यान से देखो तो फर्स्ट ऑब्जर्वर के लिए जो वर्क डन है वही मेरा ग्राउंड वाले ऑब्जर्वर के लिए भी है ना जी। तो पॉइंट क्या है कि हम पोटेंशियल एनर्जी फाइनल माइनस इनिशियल इसलिए और कंसिडर करते हैं कि अगर इफ आई टॉक अबाउट रेस्पेक्टिव पोटेंशियल एनर्जी इट इज डिपेंडेंट अपॉन डेफिनेटली ऑब्जर्वर्स, but the change in potential energy, what is the condition that this change in potential energy is totally independent? No, not change is magnitude. Change in potential energy means p final minus p initial. Are you able to get me or not? What signs are opposite? Huh. Minus mg h1, look over there, that is just the negative consideration. Here I just wrote p final minus p initial. That's how I got it. Are you able to get me or not? Okay. So negative is just showing its sign. Are you able to get me or not? Negative over here was just to bring the consideration that work done by conservative force is negative of p final minus p initial, which we are using over here. Is that clear or not? वरना वो तो नेगेटिव ही आएगा ना. Are you able to get me? सो बेसिकली द पॉइंट इज अगर मैं यहाँ पे नेगेटिव साइन नहीं यूज करता तो क्या आता? नेगेटिव ही आता. तो हमने यहाँ पे ये फॉर्मूला बनाया ना कि वर्क डन बाय कंजर्वेटिव फोर्स इज व्हाट? नेगेटिव ऑफ पी फाइनल माइनस पी इनिशियल आफ्टर गेटिंग दैट वर्क डन इज माइनस ऑफ mgh1. आर एबल टू गेट मी? मेरी बात समझ में आ रही है क्या? तो इसका मतलब क्या हुआ? इसका मतलब अभी बेस्ट कंक्लूजन निकला कि सर हमें मालूम है कि अगर मैं पोटेंशियल एनर्जी ऑब्जर्व वन से निकालू सिर्फ तो दैट इज एम जी एच वन, सिर्फ टू से निकालो तो वो क्या है? एम जी एच टू है. लेकिन अगर हम दोनों के वजह से चेंज इन पोटेंशियल एनर्जी निकालते हैं तो वो कैसा है? हरदम सेम है. कैसा है? हरदम. अगर चेंज इन पोटेंशियल एनर्जी हरदम सेम हो गया तो क्या मेरा वर्क डन भी विद रिस्पेक्ट टू डिफरेंट ऑब्जर्वर्स विल बी आल्सो सेम? या so that means if I have conservative force, which kind of force? Then one more point adds over here that work done over here is independent of observer. And here it will be dependent on observer. Is this clear or not? So this was all your conclusion about conservative force and non-conservative force, where the work done by any kind of conservative force is given by only one equation, that is negative of change in potential energy, which is minus of P final minus P initial. PE I should use actually, okay, which can be also written as P initial minus P final. और इसके पीछे भी रीजन है, ये ऐसा होगा क्यों, ये इसके पीछे भी रीजन है, ध्यान से देखो। तो जब भी हम वर्क करेंगे तो बॉडी के ऊपर काइनेटिक एनर्जी आएगी ना, तो क्या वो पोटेंशियल एनर्जी को हरदम घटाएगी ना? इसीलिए अगर हम पॉजिटिव वर्क करते हैं तो पोटेंशियल एनर्जी हरदम क्या होता है, घटता है। आर एबल टू गेट मी और नॉट? सोचो जरा कि मतलब, या बेसिकली सिंपल सी बात है कि अगर हमने वर्क किया किसी बॉडी के ऊपर, तो बॉडी की जो रेस्ट की कंडीशन है वो क्या चीज में चेंज हो जाएगी, मोशन में। क्या चीज में? और जैसे ही बॉडी मोशन में आएगा उसकी पोटेंशियल एनर्जी बेसिकली क्या हो गई, घट गई। आर एबल टू गेट मी? And that is why we consider that work done by conservative force is P initial minus P final. Are you able to get me? मेरी बात समझ में आई या नहीं आई? Is this clear or not? अब ध्यान से देखो, तो we know that work done by conservative force is which kind of nature, reversible, isn't it? That means it is only reversible if total energy is always remaining constant. Yes or not? Total energy always remains. How is that possible? If how the total energy will be totally constant if the initial kinetic energy plus initial plus initial potential energy will be equal to final kinetic energy plus final potential energy. Are you able to get me or not? So basically the law of conservation of energy is only applied for which kind of forces, conservative forces. किसके लिए सिर्फ? क्या ये नॉन कंजर्वेटिव वाले कभी एग्जिस्ट करेगा? नहीं, क्योंकि फॉर नॉन कंजर्वेटिव फोर्सेस व्हिच काइंड ऑफ नेचर इज देयर, इरिवर्सिबल। व्हिच नेचर? एंड दैट मींस दैट एनर्जी इज ऑलवेज चेंजिंग। आर यू एबल टू गेट मी? मेरी बात समझ में आई या नहीं आई? इज दिस क्लियर और नॉट? चलो तो कुछ क्वेश्चंस करें। मान लो एक ब्लॉक है, एक इंक्लाइन प्लेन है, दो इंक्लाइन प्लेन्स है। There is no collision we are going to talk about, okay? And from both of the inclined planes, two objects are dropped. दोनों से दो ऑब्जेक्ट गिरा रहे हैं ना, एक एक ऑब्जेक्ट। एक की मास है यहाँ पे 2 kg, इसकी मास है 3 kg। यहाँ पे ये एंगल ऑफ इंक्लाइनेशन 53 डिग्री है, यहाँ पे कितना है, 37। ठीक है। अगर दोनों के केस में बेस लेंथ दिया हुआ है, क्या दिया हुआ है? इज दैट क्लियर और नॉट? Then let's suppose if this is 4 meters and this is also how much meters, sorry, 3 meters, then the question arises that find the, let's suppose this is block A, this is block B, find V of A with respect to V of B at the bottom of track। बताओ जल्दी से, 2 मिनट टाइम हमारे पास, जल्दी से बताओ। Do we? What? Why to use constraint motion? Think of the case. 2 minutes of time. One minute. I'll bring my phone. Do it. Mm-hmm. Think. मतलब कैसे होगा ये सोचो। आसान क्वेश्चन है, ऐसा नहीं है कि हार्ड है ना। अच्छा, एक्चुअली में होना क्या चाहिए बेसिकली? सरफेस स्मूथ है। सरफेस कैसा है? कंसिडर कर लो कि सरफेस कैसा है। स्मूथ, यस। अगर सरफेस स्मूथ मानोगे तो हो जाएगा, आसानी से हो जाएगा। थिंक। यस, देयर इज ओनली वन फोर्स एक्टिंग। सोचो। हाँ, थोड़ा बहुत रेशियो तो निकालना पड़ेगा। Downward forces will not give you anything. that can do a little bit work, but that will take a lot of time. ठीक है. बताऊं मैं. अच्छा, एक एक बात सोचो, ध्यान से सोचो, अगर मान लो बॉडी स्लाइड कर रही है, यहाँ फ्रिक्शन है नहीं, ठीक है ना. तो जब फ्रिक्शन नहीं होगा, अगर अगर हम सोचते हैं कि अगर फ्रिक्शन कुछ है नहीं, तो अगर कभी भी फ्रिक्शन नहीं हो तो यहाँ पे क्या सीन होगा कि सर जो भी फोर्स लगेंगे वो कंजर्वेटिव इन नेचर लगेंगे. एंड फॉर कंजर्वेटिव फोर्सेस एनर्जी इज कंजर्व्ड ना. देन अप्लाई दैट. ओके. अप्लाई इट, यू विल हैव टू टेक सम टाइम. चलो बताऊं मैं, चलो मैं करता हूँ, ठीक है. अब ध्यान से देखो, चलो आ जाओ, लेट अस फोकस ओवर हियर. अब ध्यान से देखते हैं इस ब्लॉक के ऊपर कैसे बनाया जाता है वो समझते हैं. अच्छा देखो, इस बॉडी के ऊपर कितने फोर्स है. पहला फोर्स है mg, है ना. पहला फोर्स कौन सा है. mg. इसके लिए भी mg, नहीं, जस्ट विल सी दैट फोर्सेस. ठीक है ना. अच्छा, इसके ऊपर फ्रिक्शन लग रहा है क्या. नहीं. एक दूसरा जो फोर्स लग रहा है वो कौन सा लग रहा है. नॉर्मल. इसका एक नॉर्मल होगा, इसका भी एक क्या होगा, नॉर्मल होगा, है ना. है कि नहीं. अच्छा, जब दोनों नॉर्मल लग गए, अगर हम ध्यान से देखें तो नॉर्मल और mg कौन से फोर्स होते हैं, कंजर्वेटिव इन नेचर होते हैं. एंड इफ दे आर कंजर्वेटिव फोर्सेस, अगर ये किस तरह के फोर्सेस है, conservative forces, then we know that basically we know in simple terms that kinetic energy initial, if I consider block A, for that kinetic energy initial plus potential energy initial will be equal to kinetic energy final plus potential energy final. अच्छा, अगर बॉडी यहां से स्टार्ट हुआ तो इनिशियल काइनेटिक एनर्जी कितनी हो जाएगी, जीरो. और अगर ये बॉडी यहां से स्टार्ट होता, अगर ये 4 है तो क्या ये लेंथ 3 मीटर्स होगा और ये लेंथ 5 होगा. अगर ये 3 है तो ये कितना होगा 4 और ये कितना हो जाएगा 5. आर एबल टू गेट मी. यही होता है ना रिलेशन. तो ध्यान से देखो, अगर ये 3 4 5 है तो सिंपल सी बात है, अगर ये बॉडी यहां से स्टार्ट हुआ तो इसके लिए हाइट की जो वैल्यू वो कितनी है, 3 मीटर से ग्राउंड के रेस्पेक्ट में, है ना. तो पोटेंशियल एनर्जी क्या आ जाएगा, 2 × ग्रेविटी 10 × हाइट इज हाउ मच, 3. और फाइनल काइनेटिक एनर्जी कितनी हो जाएगी नीचे, हाफ एम बी स्क्वायर. यही होगी ना. हाँ, मास कितना हो जाएगा 2 और वी स्क्वायर. और अगर ग्राउंड पे ब्लॉक आ जाएगा तो हाइट की वैल्यू कितनी होगी, जीरो. फाइनल पोटेंशियल एनर्जी कितना हो गया, जीरो. दिस basically 2 and 2 got cancelled, and v of a square is nothing, or v of a is nothing but what, root under 60. Yes. Similarly, if I look for block B, what will happen? Same kinetic energy initial, conservative forces are only there. So kinetic energy initial plus potential energy initial will be equal to kinetic energy final plus potential energy. Final. Are you able to get me or not? What is its initial kinetic energy? Once again, zero. Initial potential energy. This time it is at how much height? 4 meters. So 4. Sorry, m 2 kg into g10 into height how much? 4 is equal to half m, which is 3 kg into vba square. And final potential energy once again on the ground is how much? 0. So what I get as equation? You get the equation as vb is equal to nothing but root under 2 to the 4. 4 4 just 16. 160 by how much? 3 meter per second. Can you take the ratio of this or not? Basically, you get the answer. Are you able to get me or not? No, no, you have no, no. You if you have to basically see the question. अप्रोच क्या है कि पहले फोर्स डायग्राम ड्रॉ करो. क्या ड्रॉ करो? उसमें आइडेंटिफाई करो कि कंजर्वेटिव है या नहीं है. अगर सिर्फ कंजर्वेटिव है तो बस टोटल मैकेनिकल एनर्जी की कंजर्वेशन लगा डालो. आर यू एबल टू गेट मी? Then we'll have to think about another equation which I am going to deal right now. Are you able to get me or not? Okay, है ना? चलो एक और क्वेश्चन बनाओ. Okay, question is we are talking about potential energy and this is most important question which is asked everywhere. Find, let's suppose a rod is standing, a rod is vertical, a rod is vertically, sorry, with a wall I hang a rod, okay, which has mass how much? M and length how much? L. Then question is find the potential energy of rod with respect to O. बताओ. Point. Yeah. MGL. Think once again. Really think once again. Think once again. It's easy peasy, man. You can use conservative force, no problem with that, yes. Mm-hmm. Rod is hanging, so that means what will happen? Kinetic energies are zero, yes, correct. Always, yes. अच्छा एक बात बताओ, किसी रिजिड बॉडी के लिए उसकी मास कहाँ पे एग्जिस्ट करती है? कहाँ पे? सेंटर ऑफ मास, है ना? तो यहाँ पे क्या लगाओगे फिर? कॉन्सेप्ट ऑफ क्या लगाओगे? सेंटर ऑफ मास. सो अप्लाई द कॉन्सेप्ट ऑफ सेंटर ऑफ मास एंड गेट द आंसर. ओके, चलो अब देखो, ध्यान से देखो. बेसिकली अगर ध्यान से देखें तो जो रॉड वगैरह कोई भी रिजिड बॉडी है उसके लिए जो बेसिकली मास होता है वो कहाँ पे एग्जिस्ट करता है, सेंटर पे। कहाँ पे? तो बेसिकली अगर सेंटर पे एग्जिस्ट किया, ठीक है, तो उसके लिए हम क्या बोलते हैं कि द पोटेंशियल एनर्जी विल बी, एंड दैट इफ इट इज ऑफ लेंथ एल, द सेंटर ऑफ मास इज लोकेटेड एट एल बाई टू और नॉट फ्रॉम द रेफरेंस पॉइंट ऑफ। So the potential energy will be what? Mass into gravity into length, how much? L by 2. बात खत्म. That is your answer. But let us just prove this. What to do? Why? Because this mass is located at what distance? L by 2 distance. Are you able to get me on? For any kind of, no, 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 no. You just confused us. Whenever there is a continuous body, which kind of body? No, a block. If it is, see. For the block, the dimensions are not given to you. Is any kind of dimension is given to you? So that's why they are treated as particle. Okay. And here I gave you the dimension. So here it will be not be treated as a particle. Are you able to get me or not? Yeah, correct. Is that clear? ठीक है. So basically, let us just prove it how it appears over here, isn't it? Okay, so let us just see of one case. How to prove it, we will see that. Now, if I have any kind of rod, okay, this is my rod which is hanging over here. I'm not drawing that wall and all. Okay, this is my rod which is hanging, which has mass how much m and length how much l. I want to find the potential energy, whether it's with this point or that point, whichever point you wanna ask. Okay, so let us consider from this point. So this will be 0 and this will be length L or not. Now, how to find potential energy? As I know, this is a continuous body. Which kind of body it is? Continuous body means the particles are very near. Now, for any kind of continuous body, you can't do any of the calculation without integration. That's so true, no? So basically, we can't do, if I follow the unconventional method, then for these kind of bodies, the only task is done through integration. Are you able to get me? How do we do it is simple, that if we get any kind of continuous body, just create a very small mass. क्या कर दो, एक छोटा सा मास का m dm मान लो, और उस जिसकी लेंथ कितनी हो बस dx, और लोकेटेड कितने डिस्टेंस पर हो. Why to consider dl? Let us just consider dx, no problem with that. Sorry, located at distance x, because l is already used. Are you able to get me or not? Understood. For any kind of continuous body, if I'm talking about ring, if I'm talking about sphere, if I'm talking about cylinder, whichever rigid body you take, just create a smaller mass element of mass dm, length dx, and located at how much distance x. Remember that this variable and this variable should always be same. Are you able to get me? So basically, a smaller mass element is equal to how much? uh, dm, and its length is how much, guys? Dx. Are you able to get me? Now, if it is a smaller mass element, I can define the potential energy of this very small element or not, and I will call it as very small potential energy, which I represent it as du. क्या जैसे represent कर रहा? So du. So basically, du will be equal to how much? My smallest mass into its gravity, and at what height? Will not consider right now as negative. I'll tell you when to consider negative. Are you able to get me? Is that clear? मेरी बात समझ में आ रही है? So now you got the point that du is equal to how much? Dm into g into x. Is that clear or not? Now let us just talk about here. If we see the variable, dm is also variable, x is also variable or not? Now then the task arises that convert this thing. Okay. नाउ फॉर राइट नाउ ध्यान से देखो तो ये जो रॉड है वो एक वन डायमेंशनल ज्योमेट्री है ना, है कि नहीं? किस तरह की ज्योमेट्री है? अच्छा, वन डायमेंशनल ज्योमेट्री मतलब सिर्फ एक लेंथ है इसके अंदर, है कि नहीं है? अच्छा एक बात बताओ, अगर मैं तुमसे पूछूं एक क्वेश्चन, व्हाट इज द वॉल्यूम ऑफ रॉड, व्हाट विल बी योर रिप्लाई? I didn't have, this is like 1D now. I didn't have given you area of cross section also. What is then volume? So the first task is to understand what is volume. Remember that the volume has a definition that it is the, no, learn it. It is the space occupied by matter. What is volume? No, it's just the space. It can be anything. It's not area. It's not even. It can be anything. It is just the space which is occupied by my matter. Are you able to get me or not? Now I'll tell you one thing. Let's suppose if I have a rod, the space occupied by my particles are only along the length direction or not? ध्यान से देखो पार्टिकल्स कहाँ अरेंज्ड है, सिर्फ लेंथ के डायरेक्शन में। तो इसकी जो वॉल्यूम है ना, वो हम बोलेंगे कि द वॉल्यूम ऑफ रॉड इज नथिंग बट लेंथ है, because the matter are only present, matter are occupying only the space in which direction? Lengthwise direction. Length only. Are you able to get me? So basically, even if I, let us take another case. Let's suppose if I take a rectangular seat, क्या लिया मैंने? एक सीट है, एक रेक्टेंगुलर सीट है, बेड सीट है ना? अब ध्यान से देखो तो इसमें जो भी पार्टिकल अरेंज है वो कैसे अरेंज है? एक तो ब्रेथ की तरफ अरेंज्ड है और दूसरा लेंथ की तरफ अरेंज्ड है। मतलब इसके पास क्या प्रेजेंट है? सरफेस एरिया प्रेजेंट है या नहीं है? तो मैट basically the matter is present in only surface area or not? तो volume of these kind of 2D objects, किस तरह के objects, is nothing but the area. We will call it as what? Area. Are you able to get me or not? And for 3D it will become just volume. Is that clear? Okay. Now I'll get right for right now. Just keep this in your mind. I'll categorize this. I'll take a class. Means the Friday class will be on this only, the distribution of particles, because I think so you do not know that. Is that clear? Okay, we'll learn that. That's an awesome class which I'm going to take. Okay. Okay. So now, basically, I got to know that for one-dimensional geometry, volume of the rod is represented by what? Length. Are you able to get me or not? So we know that. So what is the formula of density? Density is equal to mass by volume. But for one-dimensional geometry, volume is equal to length L or not? So we define a special kind of density for one-dimensional geometry, and we call it as linear mass density. Yes. Are you able to get me? No, no. It's linear mass density. You call it as linear mass density. It's correct. Okay. And that's why lambda is equal to what? M by L. Because volume of the rod is exactly equal to length. Are you able to get me or not? So we are not doing anything. We are just keeping the density. Density is equal to mass by volume. But here volume is length L. So I start calling it as linear mass density. Are you able to get me? Now, if it is a uniform cross section, I know that whenever, 1 minute, sorry. Whenever if we have uniform cross section, just like this rod, we know that if I find the M by L for this bigger length, whatever is that density, and if basically density tells about what? What is the definition of density? Density is my number of particles per unit volume now. Density is not mass or something like that. It is what? Number of particles per unit. So when I talk about a linear rod, एंड इफ माई डेंसिटी इज यूनिफॉर्म, क्या है डेंसिटी? तो इस बड़े लेंथ में जितने नंबर ऑफ पार्टिकल्स होंगे उतने ही नंबर इस छोटे से भी लेंथ में होंगे ना. So basically, if this length is very small, I call it as dx. So density, and I call this as it has mass how much? Dm. So density, if the density is uniform, then it must be exactly equal to total mass by total length. And for chota mass by chota length also, it should be same or not? dx. So that's what we bring it. That कोई भी mass density जो होता है वो बड़ा mass by बड़ा length is equal to छोटा mass by छोटा length होता है अगर density कैसी है बेटा? Uniform. Is that clear or not? And here it will be given to you. अगर देखो, अगर मास दिया हुआ है तो वो यूनिफॉर्म ही है ना. अगर वेरिएबल होगा तो वेरिएबल बराबर लिख सकते हैं कि नहीं, उसका अपन बात करेंगे कल कल के बाद. इज दैट क्लियर? ठीक. तो बेसिकली अगर ध्यान से देखो तो यहाँ पे मास दिया हुआ है और लेंथ एल दिया हुआ है ना. तो डीएम का वैल्यू क्या आया? एम बाई एल इंटू डी. पुट इन दैट इक्वेशन. du is equal to m by l into g into x dx integrated. X varies from 0 to length L. So initial potential energy at 0 is 0. Final potential energy become U final, and this is m by L into g. X का integration क्या होगा? X square by 2 होगा. So directly I can write it as L square by 2 or not. So that is written as what we got over here. Are you able to understand me or not? Is this clear? ठीक है, आगे बढ़े, है ना. हम्म. चलो एक बात बताओ, एक क्वेश्चन है. हम्म, क्या दिया जाए? Let us just okay, yeah. Now let us think that I have a pendulum, okay, and I drop the pendulum from a length of 5 meters and at an angle of 37 degree. Mass of the bob is 2 kg, and from this point it is released at t is equal to 0. Okay, then the question is find the work done by the tension when it reaches mean point. Do this thing. I do not know. Yeah, at mean point tension is exactly equal to mg. That is so true, correct? But how do you forgot that at mean point I'll have a velocity also, isn't it? If I drop from any released position, then the particle will have definitely some velocity at mean point or not. So at that time, tension becomes what? Mg plus mv square by r. Do you remember that? Got it or not? Mhm. Follow a circular motion notes once more, and then we'll have a clear idea of this. Is that clear or not? Do this question then. बताओ क्या होगा. क्या होना चाहिए सोचो, जल्दी बताओ। इजी पीजी है। अच्छा ध्यान से देखा जाए, आगे बढ़े। I'll tell you. Once again, I have told you many times. First, resolve the forces. How many forces are acting when it is released? Mg and tension. Yeah, Mg and tension T or not. Now, if the particle, when the bob will reach over here, look over there. From if this is my reference point, then this was my initial height or not, and this is my height final. Are you able to get me? So if this is 37 degree and length is 5 meters, can't I find this initial height? What will be the relation? I can write na sine 30, sorry, cos 37. No? I can write cos as initial height base by hypotenuse. Hypotenuse is how much? 5 meters. Are you able to get me? Cos 37 is basically how much meters? Cos 37 is 4 by 5. So height initial was how much? 4 meter with respect to reference point. Are you able to get me or not? Is that clear? If I got my height as 4 meters and finally the height is becoming how much meters? 5 meters. And again I look over these forces. This is my tension and this is my mg or not? Both are which kind of force? Both are which kind of force? Conservative force, isn't it? Now, if I have conservative force work done by any conservative force like tension T or mg, both of them will be same, and that will be just change in negative of change in potential energy of the system or not. How much is that? Minus of P final minus P initial. How much is that? Minus P final is what? Mass into gravity 10 और height finally क्या हो जा रहा है? 5 meters हो जा रहा है ना? That will just provide us velocity or not? I asked you work done. I didn't have asked you the particular case of that velocity. Is that clear? Understood? So now this is 2 into 10 into 5 minus initial potential energy was how much? It was 2 into 10 and it was at height how much? 4 meters or not? So what do you got as equation? This is minus of 5 to the 10, 100 minus 4 to the 8 and that is how much? Minus 20 joules. कितना हुआ? Minus 20 joules. Are you able to get me or not? So that's my work done by tension or mg, which has came as negative. Are you able to get me? Now this brings us into a conclusion that why negative. So I should develop some sign convention. So it was told that if you have the reference point, which kind of point? Then if I measure the potential energy up above the reference point, whether upgoing particle or downgoing particle, whichever particle, okay, let's suppose this particle was over here, it was still going up, and this potential particle is over here, which is coming down, and this is having height h. So this implies that if I have the reference point and if I measure up at the reference point, the potential energy, although it is going up or down, I don't care a shit about that, but my potential energy will be always what? Positive. कैसा रहेगा हरदम potential energy? It is positive. And if you measure down the reference point, whether it is going down or up, the potential energy is always negative in nature. Are you able to get me? Is that clear? So this was all related to potential energy, work energy theorem, and conservative force nature, formula of conservative force, and types of conservative force. Are you able to get me or not? So tomorrow we are going to combine this with what? Spring and non-conservative force, and then we'll do one day problems and then one day for equilibrium and statics. Are you able to get me or not? So these are, then my work energy power will